Um, Now here we've got some details of an actual implementation, and the key point of this slide is that when you strengthen your network security with an entanglement-based channel for the generation of keys, you don't have to throw out the classical high bandwidth encrypted network that you already have. So here, the blue shows Alice and Bob, site A and site B, with a hardware encryptor that's in the blue box, probably a blade in their classical router that is able to encrypt traffic using a more secure method like AES. Maybe it's an AES 256-bit key. And these hardware encryptors run at a speed such that the blue cloud, which represents their classical network, let's say it's an IPsec VPN, it can run at hundreds of gigabits per second of encrypted traffic, which is then decrypted by the same key on the other side at site B. What we've done here to make those keys more secure is we've removed the public key cryptography channel for agreeing on keys, and we've replaced it with a quantum channel, which is shown in the pink boxes. It could be the same fiber and just a different wavelength, or it could be a different fiber, but that's where the laser that generates entangled photons sits, and the photon detectors at each end, and that's where you use entanglement to generate those keys, identical, truly random, never exposed on the network. They're generated over and over again at site A and site B, and then there are secure methodologies to pass the key up to that encryptor, like the Cisco SCIP protocol or some of the ETSI standards, for example. That's what we show here. And again, you don't have to get rid of your classical network. You can still use the encryption or the secure communication protocol that you have been using. We show at the top right. You can use MACsec if that's what you're using today. You can use IPsec. You can use TLS at layer 4. You can use layer 1 encryption. It's just that now your keys are generated. They're not exchanged. They're generated identically using an unhackable method.